The James Webb Space Telescope does not issue warnings. It is a machine, a 6.5-meter mirror floating 1 million miles from Earth, collecting ancient photons and converting them into data. It does not speak. It does not predict. It does not have opinions about what it finds. But in the spring and summer of 2026, the data it has been returning to Earth has been producing a convergence of results so alarming, so consistent in the direction they point, and so fundamentally at odds with the models that physicists and cosmologists have built over the past century, that the scientists analyzing it are now using language that is unusually direct for academic literature. The universe formed galaxies too quickly. It built black holes too large too soon. It produced star systems merging in ways that required multiple generations of stellar death before the models say they were possible. It created an explosion 7 hours long when the physics of explosions says that is impossible. And it revealed a galaxy spinning at exactly the rate it should, 0, when every model of galaxy formation says that a galaxy born in the first 2 billion years after the Big Bang cannot have shed its angular momentum before it could even reach maturity. One by one, in papers published across the past 12 months, JWST has delivered results that do not fit. And the cumulative message of those results, assembled together, viewed as a pattern rather than as isolated anomalies, is a warning about how much of the universe science does not yet understand. The explosion that broke the physics happened on July 2nd, 2025. High-energy observatories detected a burst of gamma-ray radiation arriving from deep space. A gamma-ray burst, one of the most violent events the universe produces. Index 21, GRB 25072b, detected by NASA's James Webb Space Telescope and a global network of observatories, lasted an astonishing 7 hours, far longer than typical gamma-ray bursts, which usually fade in under a minute. Gamma-ray bursts come in two varieties. Short bursts, lasting less than 2 seconds, are produced by the merger of two neutron stars, the incredibly dense remnants of dead massive stars, colliding and releasing energy in a cataclysmic flash. Long bursts, lasting between 2 seconds and a few minutes, are produced when a massive star collapses directly into a black hole, driving a jet of material outward at close to the speed of light. Both types are well understood. Both have been detected hundreds of times. Both have theoretical frameworks that predict their durations, their energy outputs, and their behavior over time. GRB 2507002b lasted 7 hours. That is not a slightly unusual long burst. That is a duration 420 times longer than the longest category of standard long gamma-ray burst. No existing model of gamma-ray burst physics produces a 7-hour emission. This gives us a unique chance to study the extremes of how stars and black holes evolve, and GRB 25072b could even be the discovery of something unexpected and new. The James Webb Space Telescope observed it across its full duration in infrared wavelengths, providing the most detailed data set ever assembled on an event that broke every classification system astronomers had built for categorizing these explosions. The event exists. The physics that explains it does not. The galaxy that is not spinning delivered a different kind of warning. Quieter, more abstract, but in some ways more disturbing because of what it implies about how galaxies form. A massive galaxy, formed less than 2 billion years after the Big Bang, appears to have no rotation at all, a trait usually seen only in much older, evolved galaxies. This challenges current theories that young galaxies should still be spinning. The galaxy was discovered in May 2026, and its significance is easy to understate if you're not familiar with why rotation matters in galaxy formation. When gas collapses under gravity to form a galaxy, it carries angular momentum, the tendency to spin, inherited from the turbulent conditions of the early universe. Conservation of angular momentum means that as the gas collapses inward, it spins faster. The same principle that makes a figure skater spin faster when pulling in their arms. Galaxies are born spinning. They orbit their own centers for billions of years. The only way to stop a galaxy from spinning is through massive gravitational interactions, mergers with other galaxies that transfer angular momentum away, or encounters with other massive structures that disrupt the rotation pattern. Those processes require time, gigayears of interaction. They are not expected to happen within the first 2 billion years of the universe's existence. And yet, here's a galaxy, 2 billion years after the Big Bang, with no detectable rotation. Ben Forrest, lead author of the study, said this behavior is typically seen only in very large, mature galaxies much closer to Earth, and this one in particular showed no evidence of rotation, which was surprising and very interesting. Surprising and very interesting is the scientific way of saying that the models do not account for it, and nobody knows why it exists. The jellyfish galaxy that JWST spotted in March 2026 added another layer to the warning. Jellyfish galaxies are so named for the long, flowing streams of gas that stretch out behind them as they move through the hot gas of a galaxy cluster, streams that look like the trailing tentacles of a jellyfish. These streams are produced by a process called ram pressure stripping, the same physics that holds your hand back when you extend it from a moving car window. As a galaxy moves through the hot, diffuse gas that fills the space between galaxies in a cluster, that gas exerts pressure on the galaxy and strips away its own gas from the trailing side. Jellyfish galaxies are not rare. Dozens have been cataloged in galaxy clusters in the nearby universe. What JWST found in March 2026 was a jellyfish galaxy existing in the early universe at a cosmic epoch when galaxy clusters were not supposed to be dense enough or hot enough or massive enough to produce the ram pressure stripping required for this phenomenon. The discovery was made using deep space observations from the James Webb Space Telescope. Jellyfish galaxies get their name from the long, flowing streams of gas that stretch out behind them, resembling tentacles. The existence of a jellyfish galaxy in the early universe means that galaxy clusters were already dense and massive enough to strip gas from infalling galaxies far earlier than models predicted, which means the large-scale structure of the universe was assembling faster than the standard model of cosmic structure formation accounts for. This result connects directly to the impossible galaxies problem that JWST identified in its first observations. The same fundamental tension between how quickly the early universe appears to have built massive structures and how slowly the models say it should have been able to do so. The bulge fossil fragment that JWST confirmed in the same period is a warning of a different kind, about how much of the Milky Way's own history science has not yet been able to read. A new study combining recent observations from the James Webb Space Telescope and 12 years of data from the Hubble Space Telescope definitively showed that Terzan 5 experienced up to 4 distinct episodes of star formation, confirming that it is not a true globular cluster. Instead, it is something much odder and rarer. Terzan 5 is a dense ancient star cluster in the Milky Way's central bulge. For decades, it was classified as a globular cluster, a spherical collection of old stars bound together by gravity, formed in a single burst of star formation early in the galaxy's history. The JWST plus Hubble combined dataset revealed that Terzan 5 is something completely different. It is a fossil fragment, a remnant of one of the primordial clumps of gas and stars that merged together to form the Milky Way's bulge billions of years ago. Unlike every other such clump, which was disrupted and absorbed into the bulge during the merger process, Terzan 5 survived intact. It experienced not one but 4 separate episodes of star formation across billions of years, each triggered by different physical conditions at different times. It is a living fossil of the Milky Way's construction process, a piece of the original architecture of our galaxy that has been sitting in the bulge, intact, for nearly the entire history of the universe, overlooked and misclassified until JWST had the sensitivity to see its full star formation history. The warning it delivers is about our own galaxy, that the objects in our immediate cosmic neighborhood are not what they appear to be, and that the most advanced telescope ever built is still finding things in our own backyard that were sitting in plain sight for decades. The little red dots, the mysterious compact red luminous objects that JWST began finding in large numbers in 2022, moved closer to an explanation in 2026, but the explanation itself deepened the warning rather than resolving it. The complex puzzle of the objects known as little red dots has gradually become more complete since their initial discovery by the James Webb Space Telescope in 2022. The latest analysis of little red dot spectra, published in 2026, confirmed that these objects are some combination of actively star-forming galaxies and actively accreting black holes, a combination that does not fit neatly into either category. Scientists have proposed one pathway little red dots can follow as the universe matures based on their analysis of spiral galaxies. What the little red dots appear to represent is a phase of cosmic history in which the boundary between a massive young galaxy and the supermassive black hole at its center was blurred, a period of co-evolution where the galaxy and the black hole were growing simultaneously, feeding each other through a shared gas reservoir, in conditions that no longer exist in the nearby universe. The abundance of little red dots in the early universe, thousands of them across multiple deep fields, is inconsistent with standard models of how many such objects should exist at those epochs. They are too numerous, too luminous, and too early. They confirm the same pattern that the impossible galaxy masses, the non-rotating galaxy, the 7-hour gamma ray burst, and the early jellyfish galaxy all confirm independently that the early universe was more structured, more active, and more complex than the models built on observations of the local universe predicted. The 4th anniversary images that JWST released in July 2026 captured Centaurus A, a giant elliptical galaxy 12 million light-years away, powered by an active supermassive black hole at its center, in unprecedented detail. Webb's unprecedented sensitivity across near and mid-infrared wavelengths cut through the thick lanes of dust that obscure Centaurus A's center in visible light, showing a densely packed tapestry of individual stars and an active, ever-changing galaxy. These images are not a warning in the scientific sense. They are a celebration of what JWST can see that no previous instrument could, but they frame the warnings that surround them in a specific way. A telescope that can cut through dust, resolve individual stars in a galaxy 12 million light-years away, detect the rotation of galaxies 12 billion light-years away, observe the duration of an explosion that lasted 7 hours across the universe, and find fossil fragments of the Milky Way's own construction hiding in plain sight. Telescope with that capability, applied systematically to the universe, over 4 years of science operations, has produced a data set that is genuinely alarming in its implications. Not because the universe is dangerous, but because the universe is different from what the model said it was, in ways that are consistent across multiple independent measurements, using multiple independent techniques, applied by multiple independent research teams around the world. The warning that JWST is issuing is not about a threat. It is about a gap, a systematic, measurable, reproducible gap between what the standard models of physics and cosmology predict and what the universe actually contains. Closing that gap will require either new physics, new cosmological models, or a level of revision to the standard frameworks that the scientific community has not faced since Einstein's general relativity. Replace Newton's gravity as the foundation of cosmological theory. The telescope did not issue a press release. It just kept pointing at the sky, collecting photons and returning data. And the data keeps saying the same thing in every wavelength, in every epoch, in every type of object it examines. The universe is not what we thought, and we need to find out why. The most distant supernova ever detected by JWST in December 2025 added one more data point to this picture. Scientists detected the most distant supernova ever seen, exploding when the universe was less than 1 billion years old, first signaled by a gamma-ray burst and later confirmed by Webb. A supernova at that distance and that epoch requires that a massive star lived and died, completed its entire stellar life cycle from formation to explosion. In less than 1 billion years after the Big Bang, that is not impossible. Massive stars live fast and die young, burning through their nuclear fuel in millions to tens of millions of years. But detecting a supernova at the edge of the observable universe in the first 1 billion years and tracing it back to a gamma-ray burst that JWST caught in real time represents the outer limit of what the telescope can do, and it keeps pushing that limit with every new observation. The cumulative picture from 4 years of JWST science is of a universe that assembled its most massive and most complex structures earlier, faster, and more violently than any model built before 2022 had room for. The warning is not that the universe is about to do something dangerous to Earth. It is that the theoretical framework that humanity has been using to understand where we came from, how the universe began, and where it is going, has gaps in it that 4 years of the